Okay, well, we got the box here, so what we're going to do now is we're going to try to pull the top off the box, look inside, check and see what's going on. This does run the CDI, capacitance discharge ignition, but we got to get into the box to find out if we're having the impulses that we're supposed to from the stator and the pickup coil. Now this has a couple of trigger mechanisms in the front that run off the crankshaft. There's a part of the stator that is for the charging system. There's another part of the stator that's supposedly there to energize the ignition system. Now, I have the factory manual. One of the bad things about the factory manual, it doesn't explain any of that. It shows you a wiring diagram and you got to kind of guess as to what's hooked into what it might do. But without anything like theory of operation or description of operation, it's hard to understand, exactly what's going on here. So you got two impulses coming from the front. One's from a magnetic pickup, such as you would find in a car, like a crank sensor. The other one is an impulse of coils that is feeding energy back into the box, just like the coils for the charging system. When you look at these stators, when you pull them off the front and you look at them, you can tell there are two sets of coils. Again, one for the generation of electricity to keep the battery charged and run the electronics on the boat, and the other one, I believe, is for the capacitance discharge on the box. If that's true, then the magnetic crank position sensor or crank sensor, magnetic impulse sensor on the front, is probably an RPM signal into the box. And so that's what I'm basing my assumptions on. But what I'm going to do is open up the box, get to the connectors inside here, back probe them, back pin them. I'll do it first with a meter to see what the outputs are. And again, when I'm cranking this, I'm going to pull the plugs out. I got the plugs loose. Okay. Pull the plugs out so I'm not cranking against compression, so I'm not beating up the starter, not beating up the engine. It can turn freely because I'm going to be cranking it a lot. So it's just a good idea to pull the plugs out and let it run free without compression. Okay. But going back to the electrical box, we got to get into this thing and see what's going on. Great. Using one of these. The other one I was using is a short one, and for some reason the flank doesn't want to lock in, so it kept slipping out of the gun. This one's a bit longer, but now that I'm not under here, I should be able to get the rest of these fairly easy. Let's see what kind of messing up here. Make sure all the bolts are all the way up. Oh, very good. Get back. Great. Are you showing yours? Okay. Right. Okay, well, I do it carefully so I don't lose any of the bolts. There she is in all of her glory. I really didn't get any water in here. This did splash some water around inside, but that's what I was thinking. Got in here and maybe compromised something, but everything in here still looks fairly good. Alright, so there are a few pigtails in here with wires that come from the stator. I have to pull those and fish them out so we can get to them. Alright, this is gold right here. I don't know if you can look at the number on it, but this is a 96 boat, and this is a 96 CDI from 97 through whatever 2000 model they made this boat, all the CDIs are the same, 3751. This one is a 3745, I believe is what it is. 1 year only. No one I know of has tried using a newer module in an older boat, but it's still a 3-cylinder CDI, so I would imagine it would work. A lot of people say, well, maybe the timing curves are different. I've heard of guys using 1100 modules with 900 engines, 900 engines with 1100 modules. Just want to make sure that if I buy one, all the plugs and connectors are the same. But, yep, we got it open. I was, if anything, I figured it might have got a little bit of moisture in because we have one broken tab here. I don't know if you can see it right here. But that didn't let any moisture in. Everything's dry in here. Really nice. This is all sealed from this. This is all dry in here. Alright, so next thing to do is get the wiring diagram, check the connectors, and start doing some testing. Alright, well there's the box. Unbolt the box here. Let's see exactly what wires go where, what connections this has. Okay, so he's got his ground hooked to the ground, and there's another ground. So all the grounds are hooked together. That's good. So if this wasn't grounded, the starter solenoid wouldn't be working or any of that other stuff. So we know we got sufficient ground in the box. And that's what the starter solenoid is hooked up to under there. Okay. A lot of grounds all hooked together in the same spot. So we have the 3 connectors for the coils. And good thing they're color coordinated, so you know which ones are which. You get these mixed up and you're going to have the firing order off. Even if you got the coils hooked up to the cylinders right, they're going to be firing out of order because this fires directly into each coil. Okay, so there's 2 more connectors. Actually 3. I can't see the other one. Okay. The other one is underneath the other one is underneath here. So I gotta get a Allen, pull the fuse block up. There they are, those little tricky son bitches. There's the one for the voltage regulator. So those are the charging wires coming in. So the brown ones, the charging wires. These are the other wires coming in from the stator. And they're purple, yellow, blue, red. Okay. 4 of them there. Okay, so just need to push down on that one clip. There we go. Alright, now comes the CDI box, I think. Oh, one more? Okay. 2 more little singles over here. Damn it, can't see with my bad eyes. Gotta feel around to see which one slides into which. There we go. Alright, I'm holding gold in my hand for anyone who's got a 96 jet ski. You wouldn't believe how long it took me to try to get this. It's a 37. No! No. This isn't gold. This is junk. 3751. See that? I was wrong. Someone sent me the wrong CDI. Made by Mitsubishi. Mitsubishi igniter. Yeah, it's supposed to be a 3745. This boat only. So I've, I guess, proven my own theory that a 3751 will work in a ski. Doesn't take away from the fact that it's still got intermittent starting issues. And ran, I mean, fabulous this whole time with this igniter. So we're going to check a few things out. Like I said, we got a special last ditch effort to try to make this thing run. If not, you know, there is one company that makes an aftermarket ignition for these boats, but since I know a 3751 will work, I can just buy another igniter if I deem that this is what's wrong. Alrighty. There it is. All disheveled and disassembled. It's got a fairly new regulator. You can see all this is nice and clean, nice and dry in here. There is a little bit of spark dust residue inside here though. I'm going to blow that out really good with a blowgun so I can get some of that out. But it is kind of a weird gray chalky buildup all around the inside of the ignition box. And anyone who's worked with high voltage ignition knows that that kind of stuff is fairly common, especially when you have some leakage of the spark discharge. So, you know, take a good look at these coils. But the coils couldn't be the problem. We have no spark on anything. So if we had no spark on one of the coils, I could see one of the coils bad, but we're not going to have it, all of them just intermittently just decide to light up or not. 2 days ago, I came out here and randomly just started up the engine. It ran great until I stopped it, tried to restart it, and had the same problem again. So I'm thinking the problem is either in the impulses or this CDI box. So let's see what we can do with some testing. Okay, so with this on the pickup coil, the green and the blue wire, resistance is 0.54 k ohms. So if we're in k ohms, that means 1,000 ohms. That means we haven't reached 1,000 yet. That means basically 540 some odd ohms. Okay, we'll be able to actually see a more detailed picture when we look at it with the meter. But this is in k ohms. I could probably set the scale down in order to read it a little more readily. But looking at our paper here. Resistance on the green and blue pickup coil wire is 396 to 595 ohms. So at 540 some odd ohms, we're in the range. It's a little bit on the high side, which might limit the amount of impulse it's able to get. That, along with some dirty contacts, may be why we're having, say, an intermittent start. But for my purposes right now, this is pretty good. At 540 ohms, we're well within our specification here of 396 to 594 ohms of resistance on the green and blue wire, which is the pickup coil. Since I have that one obviously hooked up, that's the one we're going to first do our waveform test and our voltage output test on. Okay, so here's the multimeter reading, 5.56 K ohms. On the other one it said 540 ohms. This one's saying 556 ohms. As you can see, it still says 0.556 K, but at least on this meter we're able to get that third numeric position. So this one has 556 ohms, still again well within our field of resistance. It's a little high up in the 500s. I'd like to see it a little bit, closer down in the 400 range, but it's not exceeding that 592, 596 specification that we were looking at earlier. So now what we're going to do is we're going to basically turn it to volts AC. Okay. And we're going to crank it over and see if we get a voltage. Okay, not getting a whole lot of voltage out of that. 0.9. Some people were saying that you'd like to see a little more than a volt out of that, especially with the engine freewheeling like that. I would like to see probably a little more impulse. But we'll go ahead and hook it up to the scope and see what kind of waveform we can get out of it, and go from there. Okay, I got the scope set up here. I got channel 1 trace. Down here I've got a 20 volt peak to peak, and I've got it centered at 0 so I can see 10 volts above, 10 volts below, and running at a 1 second time base across the screen, which, if it's putting out a signal, should give us a fairly decent signal. I could speed it up a little bit and get more definition out of it. So why don't we go ahead and got the probe here, 20 volt scale, 1 second down here. I'm going to go ahead and maximize the window so we can see the biggest waveform possible. And that is a perfect AC waveform from a pickup coil. Exactly what I would expect to see from a crank sensor. So I know it's putting out, and that's a pretty big waveform. Okay, we're getting about, I'd say, 8 to 8 peak to peak. Maybe a little less. Yep. 6 to 6 peak to peak, so that's a 12 volt signal going across there, 12 volts AC. I don't know why my meter, I can understand why the meter does that. The meter reads an average of what's going on, and so if the signal is slow enough, the meter, as you saw, was jumping from 6 to 9 to 8 to 7, because the meter only refreshes 4 times per second. Okay, so this has an infinite amount of refresh rate because it's a scope. It's actually showing you the waveform. So now I'm actually able to see peak to peak. I have a really nice signal of 12 volts AC on cranking. And that's why it pays to have a good meter. Not a craftsman. So I know that signal's good. I've verified that. We've got the right resistance, and it's putting out a fairly hefty voltage signal. Now again, like I said, I don't know if the igniter uses this signal as the trigger to actually fire the coils. I'm not thinking so. I'm thinking they use this one as an RPM signal. But a lot of times RPM signals are also used by the computer to wake things up and make sure things run. Okay. A lot of times when you lose RPM signal, it shuts everything down, like the ignition or the fuel system on a fuel injection system. So one more time. And again, it sounds weird because I pulled the plugs out. I don't want to overstress my starter because I'm going to be cranking it over a lot. And because it allows it to run a little bit faster, I got a really nice, concise waveform. That's absolutely fabulous. So let's go on to the next. Alright, so this is our second coil. This is actually one of the stator windings. This is the purple and the red wire. Okay, so 0.4748 kilo ohms. That means it's riding right on the ragged edge of 479 to 480 ohms. Which again, if we look at our paper here, okay, on the exciter coil, purple and red, 348 to 523, perfect, right in the range. Okay, so since we have that, let's see what we get for a cranking voltage. This one says that the purple and red wire is supposed to have 40 volts AC. So I'm going to set the scale up, probably use the same time base, and see what kind of wave file or waveform we get from that coil. Okay, so I got the scope set up to the 50 volt voltage base. Okay, again, centered right between 20 and 25. We're at the same 1 second per division or per screen time element, so we'll see what kind of waveform we get from this. And oh my goodness, what a waveform. That was as pretty as I could have imagined it. Okay, but still too high. So we're going to go to the 100 volt base. I'm going to actually speed it up just a little bit, 500 milliseconds, so we can get a wider look at the actual waveform. Woo, it's still peaking out. So go to a different voltage base, go to the 200 volt scale, and see what happens there. This thing is kicking out some serious voltage. So again, those voltage readings that we saw on the piece of paper were from a multimeter that was averaging these pulses as it was looking at it. For some reason it wasn't registering peak-to-peak voltage like I would expect it to, but it could be just a cheap meter. There we go. I'm starting to see the tips and the bottoms. Okay, and that's at a 200 volt scale. There's 100 volts here, there's 80 volts there, so it is kind of coming down off the scale here. I can bring this down a little bit, and now we'll be able to see the tops. Oh my goodness. That is an absolutely perfect waveform. So we know we get that. We know that's hitting the ignition box 100%. So that's, again, starting to point me in the direction of the possible igniter box. But again, you don't just put components in, try them out, and see if they work. The whole idea behind this exercise is to show you exactly how to test these components to make sure that you're not just throwing things at it. Because I've seen stators go bad. I've seen pickup coils go bad. I've seen all kinds of weird stuff happen, and people obviously go for and replace the most expensive part. And as I found out yesterday, my part isn't even the right part for this bike. But But because the wiring harness is the same, the wiring is the same all throughout the years. Again, like one Kawasaki tech said, it's probably just a difference in timing curves. The high performance ignition system that they make for these doesn't care what year you put it on, and it has multiple timing curves, so I'm really not too worried about it. Okay, so basically what I have is a box out of a 97 to 2000 whenever they stopped making the ZXI 1100. I'm going to have to buy another one, I guess, if it turns out that everything else checks out fine. So far we had the pickup coil, which is like a crank position sensor in a vehicle. That ohmed out and also gave us a fantastic waveform. And again, we have the stator putting out a good 200 volts peak to peak. 100 here, 100 to there, that means roughly 108, I would say 180 to 200 volts peak to peak. And that's more than substantial enough to be able to throw through an igniter and make some serious spark through your coils. Okay, so let's go on to the next test. Alright, so we got the scope hooked up to the stator. We're going to look for the AC voltage coming off the stator. This would be the impulse voltage that the CDI is using to direct into the actual coils. Okay, so I have it on the 200 volt scale. That's 200 volts peak to peak. Basically about 100 volts here on the top. I can see almost 90 volts here on the bottom. And again, I slowed it down. I actually sped it up, sorry, to get a better look at the actual waveform. With these scopes, it's good to dial in your waveform in order to be able to see the actual amplitude and see a good dynamic version of it. If the time base is too slow, then it looks like a bunch of scribble on the screen. You can't see any definition. If you get the time base too low or too high, either you can't see the peaks of the signal, or you can't tell the amplitude, at least correctly within reason, of what the signal is doing. So let's take a look. Oh my goodness, that is a fantastic signal. I couldn't ask for anything better than that. And it took up basically the whole screen here. If I wanted to come back into my settings and I wanted to go a little bit slower, like the 200 millisecond per screen division, I go back, hit it back into my screen mode, and now I'll see a more defined version of that waveform. Okay. Beautiful. And I'm seeing it right peak to peak. I'm not having the peaks go far off the top or the bottom, so I have this pretty set pretty well. So I have the bias right about in the center. That's an absolutely fantastic waveform. There's no stuttering in it, there's no intermittence, there's no glitches, there's no waving about it. It's absolutely rock solid across the screen every time. And you gotta love that. Alright, so let's get on to the next test. Alright, so for our next test, we're looking at the other coil wires, the yellow and black wire. It's supposed to be between 21.6 to 32.1 ohms, the yellow and the black wire. So what I've got here is 29 ohms. I mean, probably not right in the middle, but it's right there where it needs to be. That's excellent. 21.6 to 32.1 ohms. So we got 29 ohms. Again, I had to change the scale. At first I hooked it up, it was on the 4K ohms scale. And so I was only getting 0.0, 0.2 K ohms, of course. At first, when you get a reading like that and you're looking for 23, 29, 30 ohms. But I realized that, oh yeah, gotta go to the 400 ohm. And now we got 29 ohms. Isn't that beautiful? That's wonderful. Okay. So, I can only imagine that it's going to put out a voltage signal as well. On this one, it's saying that the yellow and black puts out a 2.9 volt AC. Now again, that's taking on a meter. So I'm going to set the scope up to probably about a 20 to 25 volt scale to start with, and then we'll work our way from there. Alright. Okay, so we have the scope set up still on that 200 millisecond base like we had on the last one. We'll see if that's still a good time base. Set it up to the 20 volt scale, and we'll see what we get for a waveform. Let's see what. Oh yeah, another perfect waveform. We're talking at least 16 volts peak to peak. Again, I can slow this down a little bit if I want to. Go to the 500 millisecond. Go back. Crank it over again. Beauteous. That's absolutely wonderful. So everything checks out. So my problem has to be with that module, with that CDI box, which they can be temperamental. But the next part of this, you're probably not going to believe. So we'll get started on the module. Again, I'm going to clean all the connections off for that as well. But next time you see me, we might be cooking something in the kitchen. Alright, one of the things I did notice was the condition of the pins. They're kind of dirty, nasty, not the kind of connection I'd want to see for the low voltage impulses that we're going to be seeing coming through there. So I'm going to clean this contacts, and I'm going to clean the female side with some Redox, which is really good for taking oxidation off of contacts. So I'll be cleaning that, cleaning the female contact for the igniter module. These are all the impulses. This has the crank pickup trigger, the magnetic pulse impulse trigger, and it also has the 3 wires coming from the stator. So we're going to go ahead and clean that up as well while we're at it. Alrighty. We got the CDI on a baking pan with some parchment paper here. Okay. That's so that the box itself and the connectors don't melt touching the hot pan. Say, what are we doing here? Well, this is something I've seen worked for a few people, so we're going to try it out. There's nothing left to do but try it out. We've checked all of our signals, all of our impulses, all of our inputs, and nothing is coming out of the box, so we need to do whatever we can to try to rectify that. The box is sealed from the front, and I don't know what they're using to seal these boxes with. Okay, but you know, they put like an epoxy resin, but if you can see these lumps, I don't know what that is. That's just like contaminant that was in the mix or something. I don't know. Floated to the top and hardened that way. Well, it may be sealed, but this is still like a shrink wrap tubing, and all these wires go through here. So there still is a way for moisture to migrate into the box. Especially if you have humidity, high humidity, or something like we had at the lake where you got water inside the compartment. It may have not had actual physical water in the box, but water may have migrated in the form of steam or water vapor. Alright, so preheating the oven to 300 degrees. And once that's done, we're going to put it in the oven and let it bake for 10 minutes, they say. So, let's see what goes on. Take this over here. Over in the oven. I want to keep it away from the heat element, so I'm up on the top or upper rack. Let it cool. And now 10 minutes on the timer. Okay, excellent. And we'll let it bake. All right, so we're coming up on 10 minutes. Should be any second now. 300 degrees. There it is. Doesn't it smell good? It smells like what happens when electronics burn. Of course. Whew. Yeah. Ow. Whew. Just a bit hot. Okay. But again, nothing melted. These are all in good shape still. Pretty hot still. I'll let all this cool down before we go and put it back in the jet ski. But there's lunch. Let's hope it doesn't eat my lunch. Because if not, a new box is 500 and some odd bucks. And then if you want a high performance ignition for these, you can get them. But they're about $700, $800. So, you know, try what we can. You know, I can't break it any more than it already is, right? So let's see if we can make shit run. Okay, so we baked the CDI box, and now we're going to go ahead and start putting it back into the electrical box, hooking up the connections, putting the top back on, getting it all buttoned up, and we'll crank it over and see if this fix worked, or if it helped any, or if we've still got the same problem. Okay, here's your for the box. No. Two. Down, 4. That one. Round. Here. There's 2 bucks. Round. All 3 rounds. Just doing 3 wires and trying to set every like this. Now each one of these wires really has a channel which they need to be fed through to keep everything nice and sanitary. We are also dealing with the box's gasket here. Just want to move that kind of out of the way so we can set the box back into place where it's supposed to be. There it is, roughly placed. Wires up, wires up. These are 2 wires, just need to be connected. Everything else is like it should be. So both a little bit, so if it's too tight, this box is not rounded. This box is chassis, this box is break the chassis too tight, so I don't need. Alright, some wires, other wires, can come back into their wires. You can test it out of the way. And we'll do all the way off. Try that, there we go. Next, we'll be putting in a fuse box back, because again, these connectors are underneath there, and then once the connectors in the trough area, so the coil wires go top. So yeah, fuse box back in. Just move like that. The end is actually broken. But over here, it's not a round piece. So we just slid out and knock it down, pull it all the way up.
wires. Coil wires. It's not real tight anymore, it's just snug. Torque back against the in town, so just very light. Alright, so we're here. Okay, so go in the middle. Under. There. And there. That's a little coil here. And this coil's sort of shooting around the connectors. We're sure the boxes are more so. There we are. So nice. Okay, so we got rounds, put that on these blocks. We got all the different blocks together, respective lines. Red line, not pinch line. That is spending space. That's good. Alright, so put the block back on, so put the block back there. Make sure that okay. Make sure they both put that in the hole they're supposed to. Okay. There's a lot of bolts in here, little tacks locating down the pins. And then move off around carefully. The bolt on the bolt off down. We'll do this now for the bolts around everything. So we discovered the position so that doesn't mess around with the handles on the cover. Go around the external bolts on the cover and have them hang down there so the gasket stays in place. So I can make sure the gasket in place. Balloons. We got the long bolts threaded in. All right. Whereas I don't mind taking these bolts out and apart with power. I don't like putting them back in because they are kind of small bolts and you can't judge what lockdown is going to be. I don't want to pull the thread inserts out of the hull of the jet ski. So if I tighten these down by hand, I'll get the natural feel of the bolt and I can know exactly how much I'm tightening it. That way I don't ever reach that crucial point. Also, this is an aluminum box with stainless steel fasteners. If you lock it down too quick or too rapidly, you might just break the box, strip the threads, and it needs all these bolts to be able to seal properly. This is a boat after all. And if you don't want water in your electronics, you got to make sure your box is sealed properly. Okay. Going crossways, working my way down just like you would a manifold or a head gasket. It is aluminum, even though I don't think it would really warp too much. Main idea is to give it even tightening. Okay, box is locked down. Hot dang. We're getting closer. See if all this works. We'll see. Light afternoon sprinkle. All right, there it is, all put back together. All right, now we're going to get into the engine compartment and see if we can get some spark on this sucker. Alrighty, so I'm going to leave the spark tester on the one that I already had. I'm going to go ahead and put the other two on their flame arresters. There reason why I'm doing that is, again, we don't want errant spark, especially in a hole, something like this. And pull my battery cable up, put the negative cables on, put the positive cable back on the battery. Okay, here's the piece de resistance. I'm going to feel with my finger and see if I feel any spark impulse. Nada, nada, nada. Nada, nada. Oh, starting to feel something. Thought I felt something. Maybe. Nada, nada. Just a chopper wire. I'm not feeling it. Not feeling it. Okay, so cooking the CDI did not work. That's a drag. Knowing that I have all the impulses and everything else is supposed to be there. So, shit or not shit? Shit beyond shit? It's beyond shit. These ZXIs are known for their no spark conditions, and more people than I, probably better people than I have chased their tail around this tree a couple of times. So keep on going, see what we can find. Who knows? It may be a bad CDI, but why it would just go out randomly like that, really didn't get wet. Who knows? So, well, on to the next thing. Okay, so in any case, when you have a problem like this, it's always good to go back to the drawing board, start fresh with a fresh pair of eyes. So I got the wiring diagram. What I did is I traced out in red and black all the power wires and all the black wires. I didn't find any power wire going directly to the igniter module, but I did find several places where power is supposed to congregate, especially in these
what you would almost call like a bus bar. Well, checking voltage in a few of these places, I found there was no voltage here on this line coming in here to this trim box, this orange wire. I read somewhere where the orange and red wire on the trim box has to have power on both sides in order for it to run. So I traced it out, found the connection underneath the bulkhead, back pinned it with the key on, no voltage. Now, with the test light connected to it, I cranked it over, and guess what? All of a sudden, voltage appeared. As soon as voltage appeared, well, the ski started to want to run. So, got the ignition on, got the test light hooked up. Right now, I don't have any voltage on that line. I don't know if it wakes up or it does not wake up. Now it starts up just as nice as you please. So, when I was looking up the thread, what the gentleman was saying, that there was supposed to be power coming in through a red wire into the trim box and out through an orange wire of the trim box. If you don't have that power coming out, this whole thing here would be dead, because this feeds all these other circuits. Okay, this one bus bar feeds all the gauges and all these other things, but there's one wire that feeds this bus bar, and it comes out of the trim module. If that trim module doesn't send that voltage out of there, then the damn thing doesn't run. So when I got my test light on there initially, there was no voltage. When I tried cranking it over, all of a sudden voltage came back, and that's when I got spark back into the system. Now, I've seen sometimes where you'll have bad or corroded connections where you actually put a load on the connection, then all of a sudden it takes a bad connection, makes a good connection again. Or pulling a little current through the actual circuit actually helps to embolden the connection. It's a weird, like I said, almost like a ghost in the machine type of situation, but that's what we were having. Like I said, when I first tested it, there was no power on that wire. By actually having to draw some amperage through the test light on that wire seems to have reconnected a bad connection of some sort. But as long as I can put a test light on that, spark comes back immediately. It's amazing. Of course, we don't want to run it too long without any water going through it, so don't want to overheat it, but starts right up and runs just as it should. So I guess I'll keep a test light on board in case it doesn't want to start. Crazy stuff. This is what you find when you try to make shit run.